Electronegativity is the ability of an atom to attract more electrons. So you're looking at this, and for the most part, except for hydrogen, that's always like the weird one, as you go across, as you go down a group or down a column, the ability to attract an electron, for the most part, decreases. Kind of stays the same here, but no. The general trend is that as you go down a group, you have a lower end electronegativity. As you go from left to right on the periodic table, you have a higher electronegativity. But notice that there is a certain group slash family that is missing. These are the noble gases. So why would the noble gases be missing? Because they don't need to attract more electrons. They already have their full octet, except for helium. So therefore, they don't need to attract more electrons. It decreases as you go down a family and increases from left to right on a period. Fluorine is the most electronegative, and why? So this is like, and don't say it's because you're going from left to right. Do not say this. It is because of all the elements on the periodic table, it has the most, it is one short of a full octet and has only 2 orbitals. So if fluorine is the most, which one is the least? It's going to be francium because it has the most orbitals and only 1 valence electron. It's not even close to, it's not going to want to get rid of, it's not going to want to take in more electrons. Put it this way, the more electronegative you are, the more likely you're going to want to gain an electron to make a full octet. If you have 1 or 2 electrons, or maybe if you're a metal, you're probably going to want to get rid of your electron because it's going to make you, that way you get closer to a full octet. So magnesium versus chlorine and potassium versus strontium. Which ones are more electronegative? So chlorine is more electronegative because it has 7 valence electrons and it will gain 1 more to make a full octet, while magnesium has 2 valence electrons. Sorry, make that kind of review. Magnesium, Lewis dot structure, has 2 valence electrons, while chlorine, these two have the same amount of orbitals, but chlorine has 1, 2, 3, 4, 5, 6, 7. So it's going to want to gain 1 more to fill in right there, and it's going to want to lose these 2 to get a full octet. Calcium and strontium, which of the 2 is more electronegative? These are both on the second group, and they're also alkaline earth metals. So calcium or strontium, which is the one that's going to it's going to want to gain it's going to gain more electrons easily. And I know they're metals, so they're not going to, but of the 2, it's going to be calcium. It's slightly more electronegative because it has the lesser amount of orbitals. So the idea is, when we talk about electronegativity, like what does this mean? So being able to attract electrons means I'm more likely to pull an electron towards my positively charged nucleus right here. So these electrons on the orbits around the nucleus, I am more likely to pull an electron closer the closer my valence shell is to the nucleus. The further it is away, the less likely it's going to be pulled down in terms of the valence shell. So again, electronegativity versus atomic number. It increases as you go across a group, but what happens here that causes it to drop to 0? What elements are these and those? Those are the noble gases. So therefore, they're not going to want to pull electrons towards it because they already have their full octet. First ionization energy, it is the energy required to remove the first valence electron. So if you notice, going across, it increases. Going down, it decreases. So kilojoules per mole, so this is ionization energy. So notice that you have your noble gases back in here, okay? So why would these have the highest first ionization energy? Why would they require the most energy to pull an electron, or the first valence electron, I'm sorry? It would be because it has a full octet or duet already, and it won't want to lose its valence electron. And don't say it's because it's the furthest on the right. I'm not looking for those types of things, and if I see it, I will take off points or you won't even get credit at all. So looking at this, ionization energy versus atomic number. So it increases as you go from left to right on a row, and up here that is neon. So notice that then it drops again, and it's because you're adding another orbital. This is the one with the most energy, that requires the most energy, I'm sorry, to remove the first electron. So this one is helium. It decreases as you go down a family and increases from left to right on a period. So examples, I already gave this one. So helium has the highest one because it only has 2 electrons and it only has 1 orbital. Which element would have the lowest? Be francium again, because it's going to want to get rid of that valence electron because it has the most orbitals, and only 1 valence electron. So cesium versus potassium, which has the highest energy? Calcium and bromine, which has the highest energy? So potassium would have the highest energy. Depending on what I ask, it could be which would have the lowest, which would have the highest. So if I'm asking for the highest, it'd be potassium, because cesium has, or say potassium has, so let's make this the highest, which is the higher of the two. So cesium has less orbitals, which are pulled towards the nucleus. Oh, that's horrible handwriting. Ugh. Calcium and bromine, which has the higher electronegativity, it's going to be bromine, because it's going to want to gain an electron to make its full octet. Calcium wants to lose 2 electrons to make a full octet. So it's going to take less energy to remove that. For bromine, however, because they're 1 short of having a full octet, they're going to want to hold on to their electrons most likely. So this is the end for this lecture for periodic trends. So if you have any questions, let me know. Take care, guys.